5.5 day 2. I know there's a bunch of letters here. Pretend they're numbers though. And we want to solve for the t. Okay, we get this t by itself here. So I'm going to get rid of these first. I'm going to subtract this over. So I have r minus p is equal to negative k, r natural log of t. And I'm going to divide to get rid of this negative. So it'll be negative r plus p equals natural log of t. Actually, I'm divided by the negative and the k. Let's do both at the same time. Okay, and then I know to get rid of the natural log, I raise it to the power of e, right? So e to the negative r plus p over k is equal to e to the ln t. Those cancel out, so I just have t is equal to e raised to the negative r plus p over k. 66, I'm solving for the n. Okay, solving for the n right here. First, let's get rid of the fractions here. So I'm going to put that over 1, cross multiply. So I know that pi times 1 is equal to a times 1 minus a, like if I distribute it through, times 1 plus I to the negative r. Okay, so this times this, just distributing it through. Okay, I'm going to subtract this over. I'm going to divide by the negative a. Okay. Yeah, we just you could take this. Usually, you'll see this negative taken through, and I'll do that in the next step, probably here. Okay. Next, I'm going to take the log of both sides. Okay, log of this side, log of this side. So yeah, so I have the log of this is equal to log of this. I'm going to use the exponent rule here and bring that out front. So I know log of pi, I'm going to distribute through it, right? This negative. So negative pi plus a over a is equal to, bring this negative n out front, log of 1 plus I. Now, to get n by itself, I'm going to divide by this. So if I divide by negative this stuff here, that gives me negative log of negative pi plus a over a divided by log of 1 plus I. Okay. Whew, that was a good one. 69, I'm going to get rid of this stuff first. So I'm going to subtract the a. I'm going to divide by the b. I'm going to get rid of your 1. So I'm going to subtract the 1. I'm going to get rid of this negative here. That makes that a positive 1 and a minus of this stuff. And I want to take the natural log of both sides. Okay. So, because I have e here, so I'm going to take natural log of this side and natural log of this side. So I have natural log of 1 minus y minus a over b is equal to natural log and e cancel, so I have negative cx. I'm solving for the x here. Okay, so I'm sorry, that's c times x there, so c times x here, not raised to the x. Okay, now I divide by the negative c. So I have negative natural log of 1 minus y minus a over b divided by c. Number 72, I'm going to divide by 10 on both sides. Remember when we just have the log function, it's log base 10. So rewrite this as an exponent. It would be 10 raised to the d over 10 is equal to I over IO. Okay, use cross multiplying techniques. I have that I is equal to I sub O times 10 to the d over 10. Okay, these next couple we're going to use the substitution idea. We're going to say that wherever I see e to the x, I'm going to put you can put whatever letter you want in there. We used u in their notes, so we use u. So e to the x, this would be like u squared then. E to the x is u. Okay, so we're substituting this in for each other. Then we can just factor and solve. Be minus 4 and minus 2. So u is equal to 4 and u equals 2. Okay, now let's plug this back in. So I know e to the x is equal to 4 and e to the x equals 2. And to get rid of the e, I'm going to use natural log. So natural log of both sides gives me x equals natural log of 4. Natural log of both sides gives me x equals natural log of 2. And those are the two answers. 78, I'm going to use that substitution again. That e to the x is equal to u. So this would be 3u squared plus 2u minus 1 equals 0, because it's solving a quadratic. So I have 3u and u, plus 1 minus 1, give me 3 minus 1 is 2. And I have u is equal to 1/3 and u is equal to negative 1. Okay. Now, substitute that in. I know e to the x is equal to 1/3 and e to the x is equal to negative 1. And I can't take the natural log of a negative number, so that one doesn't work. But here I have x is equal to the natural log of 1/3. Okay, 81, I'm going to get it equal to 0. Okay, this would be like my middle term. Okay, so I'm going to use that u is equal to e is a 2x. So this would be, I'm sorry, 3 to the x. I'm going to say 3 to the x is my u. So this would be 3 to the x, which is u squared, 12u plus 35. Factor it. And u is equal to negative 7, and u is equal to negative 5. Now plug this back in. I know that 3x, 3 raised to the x is negative 7, and 3 to the x is equal to negative 5. We had said with these, you can take the natural log or log of both sides, it doesn't really matter, but do it the same to both sides. We usually use log. So I can say log of 3x is equal to the log of negative 7. Remember, bring your x out front. Okay, and I'm sorry, right here, this should have been, I take that over, subtract that over, makes both of these negative, which would make both of these positive. So then, yeah, that makes more sense. So x is going to equal log of 7 over log of 3. Same thing over here. You know, log of 3 to the x is equal to log of 5. Take the x out front, power rule. So x is equal to log of 5 over log of 7, log of 3. Okay, we could rewrite these. Yeah, we'll leave them at those. Well, yeah. Okay, number 84. I'm going to say u is equal to my log of x. That makes u squared minus 6u minus your 7 equals 0. So So u minus 7, u plus 1, u is equal to 7 and negative 1. Now plugging it back in, that makes log of x equal to 7 and log of x equal to negative 1. Changing to exponents, remember this is log base 10, so we have 10 to the 7th is equal to x, and 10 to the negative 1 equals x. Yeah, and 10 to the 7th is a pretty large number, and this would be 1 over 10. '87 asks us to solve it analytically and then use the graph to solve for less than and greater than or equal to. Okay, so analytically, I'm going to subtract the 5 and divide by 2. Okay, e, I'm going to take the natural log of both sides. So those cancel out. You have x is equal to the natural log of 5 over 2. Natural log of 5 over 2 gives you about 0.9163. Okay, that is roughly about what it is. Okay, now for part B, I'll put it down here. For part B, we want to know where it is less than 0. And for part C, we want to know where it's greater than or equal to 0. Okay, so by looking at this graph here, this graph right here has an asymptote at 5 and comes down like this, right through here at almost 1, at 0.9, whatever. Okay, so where is it going to be less than 0? So less than 0 is here over here, from here to here. So from natural log of 5 halves to infinity, or you can use your decimal there as well, either way. And greater than 0, okay, it's going to keep going forever, so negative infinity to the natural log of 5 halves. Oh, it says or equal to, so we're going to need to put this here, don't we? Number 90, I'm going to add the 2 to the other side, and I'm going to rewrite this as an exponent here. So I know that 2x minus 4 has to equal 1. And I'm going to add the 4 over and divide by 2. I get 5 halves. Okay. Now, if I look at the graph of this looks like this. Okay. So at 5 halves is my solution there. That's where it's equal to 0. Okay, for part B, I want to know where it's less than 0, so from negative infinity up through 5 halves. And part C is greater than or equal to 0, so from 5 halves through infinity. Or equal to, make sure you have the bracket there. Okay, I'm going to subtract the 8 over and divide by negative 4. Okay, so since I have a log, I'm going to turn it to an exponent, so I know that 5 squared is equal to x, so therefore x equals 25. Okay, now I got to get a graph of this. This graph looks like this, and it goes through right here at 25. So part B, where is it less than 0? Okay, be from 25 through infinity. Part C, where is it going to be greater than or equal to 0? Be this part here. So actually I didn't draw that right. I should have an asymptote here. I should have an asymptote right here at 0. So it doesn't come over here. Okay, so it only goes from 0 through 25. Okay, 96, I can use the quotient rule. I can say this is the natural log of x minus 1 over x plus 1. Okay, with natural log, I can take e to that power, so those cross out, so I have x minus 1 over x plus 1 is equal to a number to 0 power is 1, same as 1 over 1, cross multiply, I have x minus 1 is equal to x plus 1. Notice when I solve that, the x's cancel out. I have no solution. Okay, so it's never going to cross. And if I look at the graph of this, it looks like this. Okay, so it's never going to have asymptote here and asymptote there. It's never going to cross. Okay, so part A is no solution. Part B, where is it going to be less than 0? Well, it's going to be less than 0. Actually, I know my asymptote's at 1 here, don't I? Okay, 1 over 1. So it's not actually at 0, it's at 1. So from 1 through infinity. And part C, where is it going to be greater than or equal to 0? Well, it's never greater than 0, right? It's going to just cross, never cross there. Okay, number 99 says to solve by graphing. So I'm going to get this equal to 0. And if I put this in Desmos, the graph looks like this. And I know my solutions are here, here, and here. So x will equal negative 0.767 and 2 and 4. Okay, so we have that equation after 2 years. We're going to put the 2 in for the y. Okay, so we're going to solve this. Start by taking that and multiplying both sides by 0.42. So I have 0.84 equals this. I'm going to get rid of this 2, subtract that over. Okay, so negative 1.16. Get rid of this, divide by it. Okay, I'm going to, this is log base 10, so I'm going to rewrite it as an exponent. So I have 10 raised to the 1.16 is equal to 100 minus x. And then just solve it. I'm going to add the x over to that side. I'm going to subtract this over to this side. Okay, and 100 minus 10 raised to the 1.16. X is approximately 85.55. Okay, so about 85.6%.